Now that we know what is order and what is degree of a differential equation, see, now what we'll do is we will try to understand how the solution of a differential equation can exist. Okay, because see, you're getting a solution in terms of dy and dx, right? It's not like a quadratic or any sort of a polynomial function where you can just substitute, right? Or you can just solve it by the formula. So there is something called as solution for a differential equation, just like any other equation. Okay, no change. It is still an equation itself. So that means you need to have roots and you will have solutions for it. Okay, and the logic remains the same. If you take that particular value of whatever it is, substitute back in the equation, you should get LHS is equal to RHS. That is what we call a solution. That means here whenever we talk about solution, okay, solution of a differential equation, say you have a differential equation, say y or d square y by dx square plus y is equal to 0. Okay, where y is nothing but a cos x plus b sin x. Assume. So I will ask you, check, is this variable or is this function y given by that function? Is this a solution to the given differential equation or not? Now, what you need to understand here is that the equation what you have, it has two important parameters. That is, you have a and you have b, correct? A and b are what we call as parameters of the function. So you can say that a is 1, b is 1. So these are two parameters, right? Suppose if the solution has a parameter, what we can call it as arbitrary parameters. So you can call this as arbitrary. Suppose if a and b or any solution you can say, okay, a function or a solution for the differential equation, if it has arbitrary parameters in it, then the solution what we get is what we call as general solution. Okay, in the sense, if you say general solution, general solution is that solution for a differential equation where the solution has arbitrary constants. Okay, so it has an arbitrary constant, or it can have multiple arbitrary constants. That becomes a general solution. Like in this case, a and b are arbitrary parameters, right? Like that. Suppose say instead of this a and b, let's say I give you 3 cos x plus 2 sin x. Now this is also a solution in the sense, even if you take 3 cos x plus 2 sin x and if you are going to substitute in this differential equation, you will still get LHS is equal to RHS. It's not that only for a and b you will get it and not for 3 and 2, right? Because a and b can assume any value. So a and b having an arbitrary constant, we are going to get a general solution. Whereas if you take a particular solution, so the next one what we have is particular solution. So this is what? This is a solution to a differential equation where there are no arbitrary constants. So everywhere what you have is a real number. Understood? So there are no arbitrary constants. No arbitrary constants. This is what we call as a particular solution. So particular solution, don't you think it's a part of a general solution? Obviously, right? So whatever the solution you have, like y is equal to whatever, if you substitute this back into the differential equation, then you should get LHS is equal to RHS. That is what we mean by a general solution or a particular solution, depending on how we are going to eliminate the arbitrary constant. Fair enough? Now let me show you one example as to how are we going to solve this one. All right. See, you have the differential equation is y double dash plus y is equal to 0, where y is equal to a cos x plus b sin x. The example what we just took right now. Now, think about it. Is this general or is this a particular solution? It's a general solution because a and b are arbitrary constants, right? Or you can say arbitrary numbers, whatever it is. So first, what do? You have y. We have y double dash, right? So first calculate y dash, correct? So first and foremost, y dash is equal to minus a sin x plus b cos x, right? What is y double dash? You differentiate it again, right? So when you differentiate it again, you will get minus a cos x minus b sin x, isn't it? So this is y double dash. Now what do? You're going to substitute this back in this y double dash. That is the differential equation. So you get minus a cos x minus b sin x plus y. Y is what? This one, which is plus a cos x plus b sin x. B sin x cancels. A cos x cancels. What do you get? 0. So LHS is equal to RHS. So we have verified that the given value, the given general solution is actually the solution for this differential equation. Fair enough? This is how you solve it. You calculate y dash or you calculate y double dash. Sometimes you have to also calculate y triple dash. Okay, then substitute it back. Then check is LHS is equal to RHS. If it does satisfy, then it is a solution. Otherwise, it's not. Fair enough? And I hope you all understood the difference. Just to recap, a general solution is that which has an arbitrary constant in it, like A, B, C, whatever, whatever. A particular solution is that which has no arbitrary numbers. It has numbers like 2, 3, 4, pi by 2, something like this. They are called as particular solution, right? So in the next video, we will solve few problems based on this one. That is the verification part. Okay, so verify. This is the solution for this one. This is the solution for this one. We will solve those problems in the next video.